Alright, this is Unit 3, Solving Quadratic Equations. In this unit we're going to build on a lot of the skills we learned last year. For instance, last year in grade 10 we talked about factoring, solving linear equations. This time, of course, since we're dealing with quadratics, we're going to be dealing with parabolas that look either like so. We got happy faces or sad faces. So that's where we're going to go. Today what we're doing is we are specifically talking about factoring. Now factoring last year we talked about kind of three different ways. If you're in my class I refer to them kind of as like the regular factoring. Then we had the AC method, that was basically where there's a coefficient in front of the quadratic. And we talked about difference of squares. Alright, so let's get started here. Is d minus 4 a factor of each trinomial? Justify the answer. Well, there's kind of two ways you can go about this. The way I'm going to take you guys through is the algebraic way. So let's get started. If we know that d minus 4 is a factor, then what can we say? Well, we can say that we know that if you take d minus 4, okay, that binomial, and you multiply it by some other binomial, such that we have, let's say, AD plus B. Now you might ask, well, why did I start with that? Well, we know that you're going to have to take D and multiply it by something here when you FOIL it out such that you get a coefficient of 2, and then D times some other D must give you the D squared that we have, like so. Alright, so we know that when you FOIL that out, it should be equal to 2D squared plus 6D minus 56. We're trying to figure out if it makes sense, if there is such a value of A and B, specifically these two guys right here, that'll make this happen. Alright, so let's give this a try. Alright, so let's go ahead and FOIL this out. We have D times AD gives me AD squared. Now I'm going to do something kind of unique here. So with our normal FOIL, we go here first, and then we go here, here, and here. Well, with those middle two ones, the D times the B, I'm just going to leave it like so. I'm going to write this as plus D and then brackets B, because the D is going to have to be multiplied by a couple things here. Alright. Now the next one, so I've multiplied the D times the B. Now I'm going to have to multiply the negative 4 times the A and D. Well, I'm going to leave the D outside, right where I have it right there. Alright. So if I leave it like that, then inside the brackets here I'm going to have a negative 4A. And then lastly, the negative 4 needs to be multiplied by the b, so you have negative 4b. Okay. Now I can say that that's equal to my original equation, like so, minus 56. All right. So we'll scroll this down a little bit. Now you might be able to see some unique things here happen. If I highlight these guys now, notice how this is AD squared and this is 2D squared. Well, what can we say? We can say, since those two line up nicely, that we know that, I'll do this in a different color, for instance, that A is equal to 2. Alright, good. So, now we can write this equation as something slightly different. We're going to have 2D squared plus D, all multiplied by B minus, and I can replace that A right here with a 2, so I have minus 8 minus 4B is equal to 2D squared plus 6D minus 56. Alright, so we're getting there. Now, if we try and take a look here, is there anything else that looks kind of similar? Well, the parts I'm going to highlight now are going to be this B right here, actually the negative 4B and the negative 56. Alright, since I know that those are the same terms right there, I know that there must be some B that when you multiply it by negative 4, you get negative 56. So you could take out your calculator if you wish, and we could go 56 divided by 4, and we get our solution as 14. And so since they're both negative, I can say that B, I'll do this in blue again, B is equal to positive 14. Alright, so now I can go and replace those ones. So I have 2D squared plus D, and then this is going to be 14 minus 8, so that's 6, so it's really 6D minus 56 is equal to 2D squared plus 6D minus 56. The last thing is, notice how this is 6D and that is 6D. Well, since those equations are the same, at the end here we can finally say that yes, it is a factor. If those at the end were not the same, as you'll see in this next example that we try, it's going to get a little funky. That means we're going to have a problem. Alright, so kind of giving this one away, but it's a good example to get going with. Alright, so same idea right here. We're just checking. We have a different quadratic right here. We want to know, is d minus 4 a factor of this trinomial? So let's give this a try. So we'll start out with 2d squared plus 13d plus 4. And I'll do this one a little bit different, so I'll put the variables on the other side just so you can see a different look. So we want to know if d minus 4 is a factor again. So we have d minus 4, my binomial. And again, we're going to multiply it by some ad plus b. Now I'm going to go ahead and we're going to use the distributive property, or what you guys are probably used to hearing as foiling this out. So we have d times ad gives you ad squared. And again, since this d is going to be multiplied by that b, and then these two terms are going to be multiplied right there, I'm going to leave the d outside of the bracket. So I'm going to have plus d all multiplied by b minus 4a. You'll notice that that was the same as the last question. And lastly, minus 4b, like so. Okay. Now, we can set that equal to what we have right here, just to break it on down. All right. Now, it's pretty obvious to see that a then must be equal to 2. So if you want to write that like we did with the last questions to make it easier, that makes sense. We know that a equals 2, so then we can substitute that in. So we have 2d squared plus 13d plus 4 is equal to 2d squared plus d onto b minus, of course, substituting the 2 in there, you have a minus 8 minus 4b. Okay, so we're trying to figure out what these missing terms are. Again, now what we're going to concentrate on is, I'll highlight these guys, we're going to concentrate on these last terms, this guy and this guy. So we're wondering, what number are we going to have to multiply this negative 4 by in order to get a positive 4? Well, you can probably figure out how that's going to work. Essentially, the algebra, if you're wondering, folks, is you just take it. You go 4 is equal to negative 4b, and then you just solve it. Well, you divide both sides by negative 4, and of course b equals negative 1. So we know that b, better do it in blue. We know that b is equal to negative 1. Alright, so back to red here, we can start substituting that, and we have 2d squared plus 13d plus 4. We want it to be equal to the other side of the equation. So this time, of course, we're substituting in a negative 1. So we have d plus d. If you put a negative 1 in there, you're going to have a negative 9. And this gives you the positive 4. Notice how everything on both sides of the equation is equal. That's equal, that's equal, that's equal, that's equal. But what about these? Since this is a 13d and this is a negative 9d, we have a problem. So what we would say is that we know that d minus 4, d minus 4 is not a factor. Alright, so that's a different type of question. I wanted to give you an example like that one because that's going to be in your assignment. Alright, so we're kind of kicking it up a notch right here. We may spend some time on class briefly reviewing how to factor, but for the most part we're assuming that in Pre-Calc 11 we're going to be able to factor. So next page. Example 2, factor each trinomial with rational coefficients. Alright, so where do we start with something like this? Well, I'll tell you one thing that I notice is that we have these decimals right here. Okay, hence they're saying it has rational coefficients. Well, why don't we get rid of them? Alright, and so I'm going to show you a method that we can do to get rid of them and make this somewhat easier for you. So we'll do this. We're going to factor out a 0.1 to give integer coefficients rather than rational coefficients. Alright, so this basically is going to take this question, which is kind of nasty, and turn it back into a grade 10 type question. So what I'm saying is if I factor out a 0.1 from this thing, alright, then you're basically saying what number do you multiply 0.1 by in order to get a coefficient of just 1 there? Well, you would have a 10. I'll stop there and see if that makes sense. 0.1 times 10 gives you just the 1 that you'd have right in front there. Makes sense? Hopefully. Now, if you take a 0.1 out of this 1.5, then of course you're going to have just a negative 15x. So basically everything's getting 10 higher. Lastly, plus 5. Alright. Now what I can go ahead and do now is I can just concentrate on this trinomial right in the middle here and factor it as I would have last year. So this was the method last year that I called the AC method. The reason is because the first term is called your A, the 10, and the last term is called your c, the 5, you multiply those together such that they have to add to that middle term, the negative 15. So I'll do this here over on the side. We have a times c is equal to 50. We're looking for two terms that multiply to give you positive 50 that have a sum of negative 15. Well, what could that be? Let's see. So we have negative 5 times negative 10. Those multiply to give you positive 50, and they add to give negative 15. Alright, so let's continue by factoring how we normally would. We just leave the 0.1 outside here. Now what we're going to do, right, if you recall from last year, is we split up this middle term. So we're going to have 10x squared minus 5x minus 10x plus 5. Makes no difference what order you put those middle two terms in. Could have been the other way, that would have been just fine. Alright, now what we're going to do is we're going to now factor. So we factor, maybe I'll underline these. You're going to factor these two terms, whatever you can out of it, and then these two terms, whatever you can out of it. So I have 0.1. Now you're going to see I'm going to have brackets inside of brackets, so I'm going to put a square one outside. What can I factor out of a 10x squared minus 5x? Hopefully you notice you can factor out a 5x, leaving you with a 2x minus 1. Alright. Now for here what we're going to try to do is we want, of course, in the brackets here for it also to be 2x minus 1, the same as what we had over there. So what are we going to have to factor out? Well, if you factor out a negative 5, you have 2x minus 1. That all works wonderful. And we're just about done. Lastly, we'll write this as 0.1. And now, if you recall from last year, this is going to be one of your factors. Okay, and then these guys are going to be your other factor. So we would have 0.1 times 5x minus 5, and then the other factor is going to be 2x minus 1, like so. All right. Now you're almost done here. Normally you would be done there, but what you need to check is, can you factor this at all any further? Well, what I would notice here is if I highlight this guy, notice that you can take out a 5 there, whereas all these other ones you can't. Well, that's what we're going to do. We're going to factor out a 5. So when you factor out a 5, that 0.1 times 5 gives you 0.5. And then inside the brackets you just have an x minus 1 and a 2x minus 1. So that would be factored completely. So make sure you noticed in that step how I did that. All right. If you want to go check, if you recall from last year, you could take that factored equation right there, factored expression, multiply it by itself, and you should get back up to the original example. Let's try the next one. I want to remind you guys, for a lot of these, I'd like you to try them on your own. You're capable of factoring a lot of this on your own, so try it, see what happens. All right. And just fast forward and see if you got the right answer. So this one's a little bit different than the one we had before. Notice how you have a fraction. Well, just like when we had decimals, why don't you get rid of the fraction? So that's what we're going to do. Just like when we wanted to get rid of the decimal we had there, we factored out a 0.1. This time, since I have a fraction over 3, I'm going to factor out a 1/3. So let's see what happens. So I'll make a little note here so you know what's going on. I'm going to factor out 1/3 to get lovely integer coefficients. Alright, so we should all be happy now. Let's see what happens here. I factor out a 1/3. Alright, now keep in mind what that means. It means 1/3 times something is going to give you an x squared. Well, of course, that's just going to be 3, right? Because 1/3 times 3 just gives you 1. Now, if we factor out a 1/3 from the 17, of course, that just leaves it as a negative 17x. And if you factor out a 1/3 from the 2, it essentially means you do the opposite. You multiply it by 3, so you have a negative 6. Alright, so make sure you understand that. Stop and take a look if you need to. Now we're back to the AC method. The AC method says we take our first term times by our last term, and it has to equal that middle term right here. So we have 3 times negative 6 is negative 18. Numbers that multiply to give you negative 18 that have a sum of negative 17. Of course, that's fairly easy. It's going to be negative 18 and then a positive 1. Just circle those guys. So now we're going to split up that middle term into being those. So we have 1/3. 3x squared. It's up to you what order you want to do it. This time I'll put the bigger one first. I'll go negative 18x plus x. So you normally don't write 1x, so get in the habit of just writing plus x minus 6. Like I said before, if you had put the 18 and that 1 in different orders, that would be fine. So we have 1/3. Now I'm going to use the square brackets because we're going to have brackets inside the brackets. We look right here. What can you factor out? Factor out a 3 Anything more? Yes, usually an x you can factor out, so 3x. What are we left with? We have an x minus